All right, welcome to Chapter 7, Section 2, Division Properties of Exponents. This is for Integrated Math 1, or IM 1. So a couple things you'll see on your screen here. So the first thing you should see is a due date. You only see that on the student side. I don't see it on my teacher preview here. The second thing is the number of attempts. You always have unlimited attempts. You can come in and complete this assignment as many times as you would like. This particular assignment has 6 questions on it, so that's what the number of questions means. And grading policy is best score, so whichever attempt is the best one is the one you keep. Partial credit is enabled, so if you answer 1 of 6 questions, you get credit for the 1 question. This says once you start your homework, you must finish it before you can work on anything else. That means once I click start here, that down in the bottom right corner, we will see the submit assignment button. From this point forward, if I want to leave the screen, I need to click that button. So whether or not I've worked on anything, or even if I've only worked on a couple, I click submit assignment. What that does is it stops the system from locking you out of all your assignments, just like that other screen said, and it makes an effect in the gradebook so we can actually see that you've been working on it. It will save your place, so as long as you've clicked check, you have a green check mark on these, it's not going to make you repeat them. If you have something typed in here and you have not clicked check, it's not going to save that, so make sure that you do, complete the problem, and then it'll save your place. On the side here, we have explanation, example, and message center. Explanation tells you you're going to lose your question attempt because it's literally going to give you the solution to the problem you're looking at. So it's not going to give you the answer and then let you come type it in. Sorry, that's not how that works. So you're going to have to come in on another attempt to try that one out. But you can click on example. And that's going to give you kind of not a general example, but a kind of specific example for this question type. So it's going to show you exactly what it wants you to do. You can read through and take a look at this example. If you want to see another example, you just click example again. It's going to open a brand new one. You can also message your teacher directly from the screen. It'll attach a picture on here so when you reach out, we know where to go help you. All right, so let's go ahead and focus in on this guy. So on the first section, we looked at the properties of multiplication when we're talking about exponents. Now we're going to look at the properties of division. So when we're using multiplication of exponents, and I know we had one like this, on section 1. So we're multiplying, we have the same base, so we're going to add the exponents. So we go 4 plus 4 equals 8, so I have 7 to the 8th power. So we add when we're multiplying the bases. When we're dividing the same bases, we're going to subtract. So we just subtract the exponent. Sorry, I want to make sure I'm saying that right. So first, before we get too far into that, it's actually going to have us practice power of a power real quick using it's power of a power and kind of power of a quotient, I guess. It's kind of mixed together a little bit here. So what we're going to do is kind of the same thing we did in section 1 here. So we have b to the 4th power, we have negative 8, a to the 3rd squared. So remember, an exponent tells me how many times I'm using the base. This is the base. So I'm actually using this twice. So what that means is I need to square everything. And this is an exponent that's just a really big exponent. I shouldn't have wrote the 4 quite so big. But if I'm using 4 twice, it means I have 8 of them. 4 plus 4 is 8, or I could say 4 times 2 is 8. I can use that power of a power rule and multiply. I also need to do the same thing to the bottom because I would also have this entire thing repeated twice. So negative 8 times negative 8 is positive 64. A to the 3rd times a to the 3rd. That's 2 of them. That would be to the 6th power. Or I could think of 3 times 2 is 6. Because that's the power of the power rule. So now I've applied this piece. And if I could reduce, I would. There's nothing to reduce here. B and A are not the same, so I can't reduce those. And this is a 1 and a 64, so those don't reduce anymore. So I simply just need to type this guy in here. I need to make sure I'm using the tools correctly. Let's see. 64a to the 6th power. Whoops. I clicked on the wrong one there. There we go. 6th power. I clicked on fraction instead of exponent. Okay, so let's check that, and we're good to go there. So let's move forward. All right, so now I'm going to show you what happens with division. I'm going to show you the visual, maybe a couple of times here, and then we'll just start using the actual rule. So this is a z. And I cross my z's so that you can tell the difference between my z's and my 2's, because apparently they look the same. So if I wanted to expand this, and I'm even going to write this kind of a little differently. So I have z, and I'm going to color code the heck out of this really quick. Let's see, I have x on top, and now I have, we'll go with pink, z to the 5th, and we'll go with green, I guess, for x to the 3rd. So lots of colors there. So let's go ahead and expand this out so we can see what it looks like. So this tells me I have 7 z's. Doesn't mean z times 7, it means z times itself 7 times. So 1, 2, 3, 4, 5, 6, 7. And there'd be a multiplication sign, like a little dot in between each and every one of these, like this. And then that's times, that's what this is. There's a times sign here. We just don't see the dots, but that's what it means. And there's one x on top. And then on the bottom, I have 5 z's. Z, 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 Z. Z, 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 Z. All right. And then I have X, X, and X because I have 3 X's there. So let me put the little multiplication sign here. All right. So when we're doing this, I don't know why that backed up on my X there. So when we're doing this, same way we would reduce any other fraction, we want to eliminate factors that are the same from top to bottom. It's just called simplification when we're looking at fractions. So if I want to simplify from top to bottom, I would just match basically 1 to 1. So if I can cross them out, 1z to 1z, they're canceled. Z divided by z cancels. Z divided by z cancels. So it just keeps canceling until I have nothing left to cancel, and then I stop. So I have these 2 z's left over. And then same thing with the x's. I can cancel z to z, and I'd have these 2 x's left over. So I would end up with z squared, there's 2 of them left, and x squared, because there's 2 of them left. So this is the visual. I can see them canceling out, basically because anything divided by itself is 1, so I can cancel 1 to 1, or z to z, or x to x, okay? The algebraic way that we look at this is I can say 7 minus 2, or sorry, 7 minus 5 is 2, and there's that 2 there. This is 1. 1 minus 3 equals negative 2. The problem with this is we haven't quite practiced negatives yet, so that might be a little confusing, but what we can think of is I'm taking 1 away, and I had 3 on the bottom, so the 2 need to stay on the bottom. That's actually exactly what the negative exponent tells me, is that it's on the bottom of the fraction. It's not on the top of the fraction. The top of the fraction is going to be whole numbers without, the decimals. It's going to be kind of bigger numbers, or bigger than 1. If it's negative exponents, it's less than 1. So it's a fraction. So it's underneath, or on the denominator. So that's all that negative 2 means when we subtract. So that can be a little confusing at first because we haven't fully gone over negative exponents. But this is kind of how we deal with that. Okay? Is we subtract, and kind of where the bigger number was, that's where it's going to kind of land. There were 7 of them up here, there's only 5 here, so if I subtract, the leftover is going to be up here. There's 1 up here, 3 down here, 3 is bigger, so the leftover is going to be on the bottom. So it just kind of depends on, again, where they land. And I think we're going to talk about negative exponents actually on the very next problem here. So let's go ahead and type this guy in. Negative, nope, not negative, sorry, just 5. What am I doing? 2x 2. Can't hit the right numbers here. All right, let's go to the next one. Perfect. Okay, so here's a negative exponent. And I don't know why this is zoomed out so far. It did. Okay, so we have 6 over 5 to the negative 1. So what this means, and it means that I have to give this exponent to both the 6 and the 5. Just like I would with any other exponent. I kind of have to distribute it here, like this. So it'll be 6 to the negative 1 over 5 to the negative 1. And what negative 1 means, like I was telling you on the last screen, is it tells me it's not negative. What it's telling me is it's in the wrong place. It should not be on the top of the fraction. It should actually be on the bottom of the fraction. And this one should not be on the bottom, it should be on the top. It's actually telling me to move it. That's kind of a way we can think of it. So I just want to move the positions of these. So I want to move 6 down to the bottom, and I want to move 5 up to the top. And then they would have the positive 1s, but we don't need to put 1 for the exponent. 1 is assumed that it's there. So really, we're just kind of flipping this guy over and writing 5/6. So that we don't have, we want to rewrite the following without an exponent anyway. So even if we did have another number other than 1, we want to apply that exponent. So if it was, squared, we want to actually square the numbers here. Which I think is what they had us do on the notes page when we did this in class. It was actually a square. All right, let's keep going here. Okay, so we have 6n to the negative 4. So again, we have a negative exponent, and they want us to use no negative exponents. They want us to rewrite it without negatives. So this negative 4 only applies to the n. There's no parentheses here. It doesn't mean that 6n is the base. N is the base, because there's only n in the exponent. We don't have it like this. So be careful. Make sure that you understand the difference between the two, because there is a big difference between 6n to the negative 4th and the quantity 6n to the negative 4th, which would mean that it was in parentheses. So, because that would mean we'd have to take 6 to the 4th power, which we're going to get a pretty big number for that. So this guy is in the wrong spot. Again, like I was saying, all numbers have a 1 under them. So this kind of is a little helpful if we remember, all numbers can look like fractions. And if we think of this guy being in the wrong spot, we just want to move it to the right spot. It should be on the top. That's what the negative is telling me. It's not a negative number. It's actually a number less than 1. So I need to move it down to the bottom of the fraction. So it's going to be 6 gets left on top. That doesn't have a negative exponent, but n to the 4th power does. Now that it's in the right spot, do you notice how I don't have a negative sign there anymore? Now it's in the correct spot, so I have just n to the 4th power. So I just move it down and I rewrite it as a positive exponent. So again, it's just letting me know it's in the wrong place. It's actually a small number. It's under the fraction. It's under the fraction bar, so it's the denominator. Okay. And this is going to be definitely important. We're going to move into scientific notation here in the next couple sections. So that's going to start to make a big difference when we have a negative or positive exponent. All right. So now it says simplify and then write your answer with a positive exponent only. So we have y to the negative 5th times y to the 3rd. So remember, when I'm multiplying two bases, I add their exponents. I'm going to go negative 5 plus 3. That gives me negative 2, because I have to subtract negative 5 minus 3, or 5 minus 3, if I'm thinking of it that way. But there's more negatives than positives, so negative 2. So I have y to the negative 2. Remember, it's under 1. So I'm going to take this piece and I'm going to move it down. So we're going to have y squared on the bottom. It becomes positive. It kind of looks like I'm swapping the 1 up top, but really everything is also multiplied by 1, just like everything is divided by 1. So I'm just leaving the 1 behind there. And there's actually still this 1 here being multiplied. I just don't have to show it anymore, because now there's something else there to be the placeholder instead of the 1. So I'm not really swapping this. I'm not flip-flopping it. I'm just moving the y down to the bottom so that I can make that exponent positive. Again, just an indicator that it's in the wrong place. That's all that means. All right. So let's see, we have 4z squared, 3z to the 7th to the negative 2. Okay, so I need to make sure that I give each one of these the negative 2. But what I can do, instead of having to remember that it's, negative 2 and I'm going to have to flip-flop this, what I can do is go ahead and flip-flop them now. So I'm going to go 3z to the 7th, 4z squared, and then I'm going to square that. It's going to be positive now. And I would have applied the negative 2 to everything anyway, but this way I don't have to remember to move everything. It's already moved. It's already in the right spot. So now I can just go ahead and apply the 2 here. 3 squared is 9. Z to the 7th power to the 2nd power. Remember, that's power of a power, so I have 7 2 times. That's 14. And then I have to do the same to the bottom. So 4 squared is 16. And then z squared squared, so 2 2 times is 4. So let's go ahead and write this guy up. So we have 9, c, 14, 16. Oh, and you know what? They're both z's. I almost forgot. We have to cancel. So 14 minus 4, because I can cancel out 4 of these from these guys, so this becomes 10. And these just completely go away. I can cancel all 4 of these. So I actually don't even have a z on the bottom because they completely cancel out. So I'm glad I noticed that. They're both z's. We need to make sure that we simplify that part too. Oh, it let me do it. So that wasn't all the way simplified. Oh, wait, yes it was. Okay, 9 and 16 don't divide into the same number. I was thinking they both divide by 3. No, they don't. 16 does not divide by 3. All right, so that was all of section 2. I will see you in section 3.